It's not just that 0 is a natural number, 0 is the unique natural number. That was, of course, on April's Fool's post, and of course, I do not believe that the Peano axioms imply that the natural numbers are the set with just 0 in it. In fact, the Peano axioms prevent that from happening. And that's because in my previous video, I on purpose omitted the 8th axiom in the Peano axioms, which says that the 0 number cannot be a successor of any other number, and in particular, the successor function cannot send 0 to 0. This doesn't mean either that I now think that 0 is a natural number. I still will write the natural numbers starting with the number 1, and that is just a convention that it's not up for debate, it's a convention. You can choose 0 to be a natural number or 0 to not be a natural number, and as long as you are consistent, it's a-okay. For example, Peano himself in the very first formulation of the Peano axioms chose 1 to be the first natural number, and in any case, I find very interesting to play with these axioms and see what happens when you remove one of the axioms and what other structures can satisfy those properties. For example, if you remove the 8th axiom, then the natural numbers could be the set with just 0 in it, but there are other possibilities. For example, the natural numbers could be the set 0 through n-1, with the successor function sending 0 to 1, 1 to 2, and then n-1 back to 0. And that set satisfies all the axioms 1 through 7 and 9. And that's interesting because in that way you can create the integers modulo n. Here's a different model for the natural numbers. What if we had 2 copies of the numbers? So we have the usual 0, 1, 2, etc. union a second copy of 0 prime, 1 prime, 2 prime, such that the successor function sends n to n plus 1 and n prime to n plus 1 prime. So what axiom in the Peano axioms prevents this from being in the natural numbers? Let me know in the comments.